So, what acronym is supposed to help us with this? Sohcahtoa, good. So if you have not written it down, I'd write it down. All right, Sohcahtoa, S-O-H-C-A-H-T-O-A, right? The O's stand for opposite. The A stand for adjacent. The H stands for hypotenuse. S stands for C stands for T stands for tangent. Okay, so this is a acronym for helping us remember the trig identities, right? The trig functions. So sine 30. This is so. Sine is good. Opposite over hypotenuse. So what's opposite 30? A. What's the hypotenuse?
C.
C. So this is A over C. Right? What's cosine 30? Good. And tangent of 30? Opposite and adjacent. So what's opposite?
A over B.
It would be. Good. Yeah, does that make sense, guys? Any questions? All right. So the next one says sine 60. Well, where is the 60-degree angle? Somewhere.
AC.
Oh, it's AC.
It's this angle, right? Because these all angles add to what?
180.
180. So 180 minus 90 minus 30 is 60. Okay, if you don't believe me, you can try it out. So we know 180 equals 90 plus 30 plus the angle we're missing. So subtract 90 and subtract 30 from 180. Cancel these out. We get 60. Right? So that means this angle right here is 60. Long. Maddie. Okay. So sine of 60. What's opposite 60? B. So sine of 60 is B over C. What about cosine 60? A over C. And tangent of 60? B over A. Right? So sine and cosine, sine of 30 and cosine 60, those are equal, right? They're complementary. Sine of 60, cosine 30, those are equal as well. And these are reciprocals, right? They're flipped over. You guys see that? Any questions? Okay. Next part. Now use your calculator to write each trig function as a decimal. So we couldn't do this with theta because theta didn't have a measure. But now that we have angle measures, our calculator can tell us what the ratio is.
Yeah.
Okay. So you're going to take a little camera over your calculator, take a picture of the triangle, and do it for you, right? Who's looking for a camera on their calculator? Okay. There isn't one, right? Because remember we learned on Friday was that if the ratio is the same, what do we know about the angle? It's the same. If I have two ratios that factor to the same thing, so let's say I have 4 over 8 and I have 6 over 12, they're both 0.5, right?
Yeah.
So that means that those two come from the same angle. They're either the opposite over adjacent, or opposite over hypotenuse, or adjacent over hypotenuse, or opposite over adjacent for the same angle measure. Right? You guys want that for Friday?
Nope.
No? Was the punchline of the activity took a whole hour to work on? That you guys try to figure it out on your own?
Yeah.
Yeah? Where if the angles, if the ratio was the same, that meant the angle was the same?
Yeah.
Well, your calculator has all those ratios stored in here. Okay? Now there's two types of angle measure. There's degrees and radians. What are we working with? Degrees. So if we're going to figure out what these ratios are, we need to turn your calculator on and hit the mode button. Mode is right next to second. Okay? It's right next to second. So the top row. Okay, hit mode. And then you'll see the third line down says radian degree. If degree is highlighted, meaning it has the black rectangle around it, it's fine. Degree is not highlighted. Move over so the rectangle is on degree and hit enter. And then you'll see the rectangle go from radian to degree. And then you'll be all set. Okay? Then hit second mode again, and it'll take you back to your home screen. All right? You need to do that every time you get started in this class. All right? Right now especially, because we need to make sure we're in degrees. If we're not in degrees, then our answers will be all wrong. One way you can figure out if you're not in degrees, if you do the sine of something, and you get a number bigger than 1, then you're not in degrees. So keep that in mind. Serena, where's your calculator?
What?
Where's your calculator? Okay, where's Alyssa's calculator? Okay, Alyssa, where's your calculator? Why don't we have calculators? Justin, where's your calculator? Over there. Whitney, where's your calculator? Okay. So you're just going to let someone else do all the work for us today? Whitney, you need yours? What number are you, Whitney? 10. 10? Anybody else?
20.
Jessica, what number are you? 14.
Yeah. Said why?
You want to take these two, Jessica? Thank you. There you go. Okay, good. So you need your calculator to make sure in degrees. So now, if you type in sine 30 and hit enter, what does it tell you?
What?
Type in sine 30. So hit the sine button.
Yeah.
2 buttons above 7. 3, 0, enter. What do you get?
0.5.
0.5. If you did not get 0.5, then guess what?
You're wrong.
You're in the wrong mode. Switch your mode to degrees. So cosine 30. What's that?
That's all we gotta do.
Ow. 0.8.
0.866, right? Tangent 30, what's that?
0.577.
Good. Sine 60, what's that? Cosine 60, what's that? And tangent of 60. 1.7 something? 1.73? Sine and cosine have to be less than 1. Tangent can be more than 1. Because sine and cosine are always divided by the hypotenuse. Alright? Alright, any questions about that? So, what your calculator just did is it found what this ratio of A over C has to be. Okay? That means if A is 3, what's C? If A is 3, what's C? 6, because 3 divided by 6 is 0.5, right? Or if C is 12, what's A? 6, because 6 divided by 12 is 0.5, right? Or if A is 4, what's C? 8, right? If C is 100, what's A? 50, right? So that way, 50 over 100 equals 0.5. Does that make sense? So that ratio has to be constant. Same thing with cosine. We do the same game. All right? Are there any questions? Now, if you look, sine and cosine are equal, right? Sine and cosine for 30 and 60, they're equal, right? Sine of 60 and cosine 30, they're equal. Tan of 30, tan of 60. If you do 0.53 or 0.577, then hit that -1 button. It's just below math. Okay? You get 1.73, which shows you the reciprocals as well. Okay? So everything we just learned, everything we do with our calculator agrees with what we've been learning so far. So don't forget Sohcahtoa. The calculator is not a shortcut for Sohcahtoa. Alright? All the calculator tells you is what the ratio of the side lengths should be. So like A over B should, or A over C. C should be twice the length of A. Alright? So if A is 4, C has to be 8. Does that make sense? This is the calculator is not a shortcut. Alright? Alright, any questions before we move on? Any questions? No questions? We got this all filled in? Yeah? Okay. So, first example on your page. If I can find my mouse. There we go. Alright. We want to use sine to find x in each triangle. Alright? Now, funny little math joke. If you do this on a test, I'm going to give you a 0. Find x. There it is. Okay. Don't do that. It'll make me laugh, but I'll still give you a 0. Okay? Only the first person got full credit for that one. Everybody else after that, they're just stealing someone else's joke. Alright? So, find x. Well, in this example, they said we need to use sine. Well, sine is so, right? S-O-H. S for sine, O for H for hypotenuse. So in this triangle, what's my theta? What's my angle? 20. So I can do sine of 20, and I know that sine is opposite over hypotenuse. What's opposite 20? 4. Right? What's my hypotenuse? X. So guess what we've created now? An algebra problem where I can find the length of the hypotenuse. No, we don't. Because we just want to find x, right? Sine gives me opposite over hypotenuse. I don't need to worry about the other one. I could find it after the fact if I need to, but I don't need to right now. Okay? So sine equals 20 equals 4 over x, right? So how do I solve this? Nope. Sine of 20 first. Do sine of 20. Take calculator, guys. Sine 20. Sine 20, enter. That's it? Okay, I like to keep at least 3 decimal places. Last hour we kept 2, that's okay too. I like to keep at least 3. I like to round my answer too. I'll show you the meaning here in a second. So now we just have a 2-step algebra problem, don't we? Right? We went from trigonometry to 7th grade algebra. Okay? Can we do this? How do we get x off the bottom? Okay, multiply by x, right? X's cancel. 0.342x equals 4. What do I do now? Divide by 0.342. So x equals 11.695. Okay. So 695 keeps going, right? You can write it like that, or I could keep 3 and then round to 2. Okay? So keep 3 for my calculations, round to 2 at the end. That's what I like to do. You can keep 3 the whole time if you want to. It's up to you. I will not mark you wrong unless you write 11 or 12. Okay? If you write 11 or 12, that's wrong.
Wait, how do you get 11?
You just forget the decimal. It's called truncating. You just drop the decimal. Okay? Or if you round this to 12 because it's 11.7. You thought about doing that, didn't you, Lon? Yeah. I don't want whole numbers here unless it gives you a whole number. If the answer is 5, great, it's 5. But if they don't give you a whole number, I need to see the decimal points. All right? All right, let's try this one. What's my theta? 38, right? What's x? Opposite adjacent hypotenuse. Opposite, what's 10? Hypotenuse. So does this say sine ratio? Opposite hypotenuse. Is it sine? Yeah. So we do sine of 30. Sorry, sine of 38 equals x over 10. Right? So sine of 38 equals x over 10. So what do I do now? Actually, I'm going to do it over here in the light. It's easier to see. Sine 38 equals x over 10. So what should I do now? Put what in the calculator, Bruno?
Sine 38.
Perfect. Sine 38. David, use your calculator to figure it out? What do we get? 0.615 equals x over 10. What do I do now? Good. Multiply by 10. 10's cancel. 10 times 0.615.
6.15.
Good. You did that in your head, right?
Sure.
All right. All right. Does that make sense, guys? Justin?
It's 6.15.
6.15 is your answer, yep. You understand how I got that, Jamira? Okay. You can without, yep, do it in your head. Alright. I want you guys to try 9 and 10 on your own, right? Take 3 minutes. I think you can do these in 3 minutes. Take 3 minutes, try 9 and 10 on your own. Need help? We know. Yep. So you multiply both sides by 10. Yep. Oh, you divided right there. It's on bottom, so you multiply by. So you multiply this by 10. Okay. Make sense? Well, see it helps. Yep. Keep 3 places. Yep. And you can run your last row too. Okay. So which one are we working on? Okay. So what's your theta? 70. So you're going. And 10 is what to 70? Opposite. And x is what to 70? No. Hypotenuse, right? So then you know sine of 70, because you have opposite hypotenuse. Sine of 70 equals divided by x. Because 10 was opposite, and x is hypotenuse. Okay? So number 9, you sine of 70. Show your work, Lauren. Yes. Because these are your notes. Equals opposite. There you go. Good. You saw that? Andrea, you enough space this time? What? Very good. David, y'all done? No? Why are you talking? All right. Where's theta? For number 9, where's theta? 70, right? So 10 is what to the 70? Opposite. What's the x? Hypotenuse, because it's across from the right angle. Does that make sense, guys? So then we know sine of 70 equals 10 over x. Right, what does sine 70 equal? 0.939. 0.9 what? 0.939, thank you. Equals 10 over x. What do I do now? Multiply by x. Perfect. Trigonometry has become a 2-step problem. 0.939x equals 10. What do we do now?
Divide by 0.939.
Good. So 10 divided by 0.939. What's x equal?
10.65.
Good. Next one. What's my theta?
40.
40. So sine of 40 equals x over 13, right, Andrea? Okay, what do I do now, Andrea?
How do you know it's
Because x is opposite and 13 is hypotenuse. You have 13 is across from the right?
Oh, yeah.
Okay. So what do you do, Andrea?
So 740.
Okay, what's sine 40? 0.613? 43? Was x over 13, is that right? Now what? By perfect. David, what do you get?
What?
Pay attention. No. What do you get? Alright. 13 times 0.63, what is that? Or 0.643? 13 times 0.643. 8.359. Okay, we'll call 3.6. Does that make sense, guys? Yeah? This makes sense? Easy enough? Okay, let's try the next ones. Now, if I look at 11 and 12, you may notice that when theta is 10, right, this 7, is it opposite?
No, it's
It's adjacent, right? So how can I make this 7 opposite?
by switching the angle.
By going to that angle, right? So instead of being 10, what angle should I use? The other one. How do I find the other one?
It's 80.
Okay. So we do 180 minus 10 minus 90. 10 and 90, right? What do we get? 80. So that means this angle right here is 80. So if I call that 80, then we can use sine, can't we?
Yeah.
What theta am I using? 10 or 80?
80.
80. Alright? So try 11 and 12. It's the same idea. Okay, 12 is the same idea as 10 as 11. Jordan, does that make sense? Kind of? Okay. Need help? Yeah. Because they all have the 180. Right? So 180 minus 90 minus 10. Okay, if I go to 180 minus 90 minus 10. 80, right? So now this is my theta. Which one's opposite? What's that? Right, what's that find? That. You do it? Okay. You do it, Kendra? Is good?
I helped him, I got it. It would be 7. Or would it be 10?
Use the 80.
Okay, right.
So which one's the side? Which one's the side? The 7 or the 10? 7. Okay. What, you good? Okay. Justin?
Well, she was
The other two, like Ka and Toa, if you want to. Yeah, you could do 11, you could do both nice. All right, ready? What's theta here? 80. So sine of 80 equals 7 over x, right? Right? What's sine 80 long? 0.984. Yes, and I multiply by x. 0.984 x equals 7. Divide by 0.984. What does x equal?
7.11.
7.11. Good. Any questions? Any questions? Okay. On the other one, can I use this 80 or should I use a different angle? What angle is that? 10. Should get a little more variation there. I'm sorry, guys. All right. So then we know that sine of 10 equals. Oh, hold on a second. Get ahead of me. Sine of 10 equals. Good. X over 5. Right? What's sine of 10, Tamara?
0.173.
0.173 equals x over 5. So now how do I solve? 5 times 0.173, what is that?
0.865.
0.865. That's a short side, huh? Alright, any questions? Now while I was walking around long side, can we use the other ones? Can we use cosine or tangents? What do you guys think?
No.
Yeah. This one right here, does this one set up better for sine or cosine? If I didn't know this was 80, this is sine or cosine?
Cosine.
Cosine, because 7 is
Adjacent.
adjacent. Right? Sitting over here, if I didn't know 10, is this a cosine or a sine one?
Cosine.
Cosine. Right? So for 12, we could do this. We could do cosine of 80 equals x over 5, right? What does cosine 80 equal? So we have 0.173 equals x over 5. Isn't that the same as what we had right here? So we get the same answer or different answer? Same answer. So you can use either way. Okay. Does that make sense, guys? Yeah? Okay. Let's try another one. Flip your page over. You'll see something look like this. Okay? Now, what's the big difference here? What's the big difference here? Whitney, I heard you say it. What'd you say? It's cosine. How do you know it's cosine, Whitney? It says it on the top, you cheater. I'm just joking. Alright. Meter source, so that's fine. But if I look at the triangle, how do I know this triangle is a cosine triangle? Good, my theta is right here, right? What's x? Adjacent. What's 6? Hypotenuse. Adjacent and hypotenuse.
It's cosine.
Good, it's cosine. That's the cop part, right? So Sohcahtoa, that's the CAH. So for these ones, we're going to do cosine CAH. So my theta here is what again? 30. So we have cosine of 30 equals adjacent x over 6. Mr. Kuhn is right on cue. Perfect. He's right on cue. He's shouting. Okay. What's cosine 30? 0.866. So 0.866 equals x over 6. What do you do? Multiply by 6. So it's basically the same problem. We're just using a different trig function, right? 6 times 0.866, what does that equal?
5.196.
So 5.196, right? So you can write that as 5.20 if you want, or 5.196. Any questions? David, does this make sense? Yeah? Okay, number 8. What's my theta? 70. What sides do I have? X and 3, right? What's the 3? Adjacent. What's the x? Hypotenuse. So since I have adjacent and hypotenuse, this is a cosine one again. So adjacent over hypotenuse. And this is why I like sine, cosine, tangent work. It seems like it's a different thing every time. It's a little puzzle. What pieces do I have? What pieces can I figure out? You like puzzles? What's cosine 70? What's cosine 70?
0.342.
0.342? Okay, China, what do I do now? Perfect. So 0.342x equals 3. Tony? What do I do now? What long say? Divide by. Good, 0.342. So x equals What'd you get, Tony? All right, wait. 8.77. 1. Nice job, Tony. Nice job, Tony. Any questions?
Can you do them all?
No, you can. Yeah. So, I want you to try 9 and 10. Oh, number 10. 25 should be 23 for number 10. Sorry about that. Okay. And your x, guys, your x is right here. Okay. So I want you to do 9 and 10 using cosine.
Can't you do a square?
You could, but I want you to practice cosine. If I told you to find x and tell you which way along, do a squared plus b squared plus c squared. But I want you to try cosine.
Wrench for number 2, we gotta do Pythagorean theorem to get the hypotenuse.
Nope, I want you to use cosine with an hypotenuse.
It's a branch.
Yeah. Yep.
Is what? 7 adjacent to them. So it'd be 7 over.
You got it. Good job, Jamara.
How are we supposed to do that branch?
Close.
Why do
No.
their
X is
why do
the
you do that? I want
hypotenuse.
every day.
Yep.
Yeah.
You're going to use 67. Okay.
Oh, I could have used
So, so which one's adjacent to 67?
I do.
Okay. And the hypotenuse can call X. Okay.
Oh.
You got it? Sometimes too much information is a bad thing, huh?
You gonna use 23.
Yeah, I wouldn't use 23.
7 over.
Good job, Peyton. Maddie, you alright?
So,
Number 11? So you want to use cosine or sine?
we can choose which one we want to use.
Well, that one, what's the 7? Is it opposite or adjacent? It's opposite. So what might you use for opposite?
Sine.
Sine. Okay. If you're done with 9 and 10 and you're moving on to 11 and 12, I want you to use cosine for at least one of them. Okay? So that means the other one you can use a different trig identity if you want to, or trig function. No, you can't use TOA yet.
Use
Why?
cosine to find over.
Because we don't, well, you have to do Pythagorean theorem and then you can use TOA. I think you'd want to do that. Alright guys, number 9, what's my theta? Justin, pick your eyes up. What's my theta?
Which one?
Number 9, what's my theta? 40. Right? So what's 10? What's 10 to 40? What's 10 for 40? Is it opposite, adjacent, or hypotenuse? Adjacent, good. What's x?
Hypotenuse.
Hypotenuse. So, if I have adjacent and hypotenuse, sine, cosine, or tangent?
Cosine.
Cosine, good. So cosine 40 equals 10 over x. When we solve this, what's x?
0.05.
X is 0.05?
No, 13.05.
Oh, 13.05. Okay. Everybody get that? Yeah? Okay. For 10, I saw a couple ways people did this. So I saw some people do Pythagorean theorem, even though I said don't. I saw some people subtract this from 180 and 90 and they got 67 and we used that one. But it doesn't matter, we should all get the same answer, right? So using 23, and I want to use cosine. So I need to identify which one's the adjacent. So which one's adjacent? 7. The x is what, Maddie? Maddie, what's the x? The hypotenuse. Okay. So cosine of 23 equals 7 over x. So when you solve for x, what do you get? Any questions? No questions? Now 11 and 12 were just like the last ones on the other one. Okay, an example, I think it's 6, or example 7. Okay? 11 and 12 were just like the last one on the sine example. If I were doing this problem, and you didn't tell me which method I had to use, what do you got to do looking at this problem? Would I use sine or cosine? I'd use sine. Because 7 is what to the 85? Opposite. Right? 7 is opposite the 85, isn't it? But the directions say I have to use cosine. So that means I need to find this angle, don't I? So you need to do 180 minus 90 minus 85. What's 180 minus 90 minus 85? 5. Right? So that means this angle is 5. So what that means is the cosine of 5 equals x over 7. No, I did it backwards. Wow. 7 over x. Thank you, Long. What's cosine of 5? 0.996. So I multiply by x, right? We divide. So 7 divided by 0.996. It's 7? 7.028. Good. Right over here. Oh, there's another one over here. No, you can't just put 7. Okay, the reason why. X is the hypotenuse, right? Can the hypotenuse be the same length as the leg? Okay. Alright, I'll let you guys try 12 on your own because I want to move on to the next one and I don't want to run out of time. So, hint on 12. Either use sine, right, opposite over hypotenuse, or find this angle. 180 minus 90 minus 18.
Are we doing tangents?
Yeah, we're in the tangent right now. So, any question on those? No. Move on to the last trig function. So we've done sine, we've done cosine, so that means these are all tangent. Okay. So this is the last parts of our acronym. This is TOA. What's the O stand for?
Opposite.
Opposite. What's the A stand for? Adjacent. Right? So in these ones, we're going to use tangents, and we're going to involve the opposite and adjacent. So if I ever know the opposite side and the adjacent side, or if I want to find the adjacent side and have the opposite side, we need to use tangent. All right? There's no way I can find the hypotenuse in this triangle yet. Well, you could, but using other trig identities. If I had to find x, the quickest way is to use tangent. All right? Because 4 is opposite and x is adjacent. So for this one, tan of 26, 26 is my theta, equals opposites over adjacent, 4 over x. Right, what's tangent 26? 0.487. So now you multiply by x, right? So 0.487 x equals 4. What do you do now? Good. So x equals,
Number.
that's right. What is it? 1.36?
1.36? No, 8.21.
8.21. So it's 4 divided by 0.487, not times 0.487.
Oh,
You multiplied, didn't you?
I think so.
Alright guys, does that make sense?
Oh, yeah.
Does that make sense? Yeah? Okay. Other one. What's my theta? 70. What's opposite 70? What's adjacent to 70? 3. Do we know that hypotenuse? No. So we're going to use tangent. So opposite over adjacent, x over 3. What do we do now? Tan 70, right? What's tan 70? Oh, it's above 1. Is that okay?
Yeah.
Yeah, for tangent, it's okay for it to be greater than 1 because you're not divided by the hypotenuse. So x over 3. So multiply by 3. 2.74 times 3. 6, 8, 8.22. 8.24. It might just be rounding and stuff. Right? Those make sense? Now for tangent, do we have to worry about subtracting the angles from 180? No. Because if we're given opposite and adjacent, we're always set up to use tangent. Does that make sense? Like you guys try the rest of these on your own. If you have questions, let me know.